Okay folks, hello, welcome back. So this is the first video I've recorded for a few weeks for this particular playlist where I'm using R&R Studio to conduct some kind of fundamental, some basic classical frequentist statistical tests. So in the last video I demonstrated how to do the chi-square test, so the test of independence, the goodness of fit test. In this and the next video I will be talking about the t-test. So the t-test is like a really commonly used test when you're comparing mean scores of two groups on some dependent variable of interest. It's one of the first statistical tests you'll learn about, I think, when you start learning statistics as an undergraduate. There are a couple of different types of t-tests, and the formula for calculating the t-value differs depending on the type of test you're doing. So there's the one sample t-test where you basically just have one group and you're comparing the scores of that group against some population mean, so the mean score for the population if you know it, or some hypothesized mean score for the population, which is often just taken as 0. One sample t-test not used that often, so I'm not gonna demonstrate or talk about them. The one that I'm going to talk about in this video though is the independent groups t-test. This is where we've got two groups and the participants, if we're talking about behavioural sciences and psychology, are different in the two groups. So we're comparing the scores of participants in group 1 with the scores of participants in group 2. The third, I guess, type of t-test is the paired samples t-test, or the within subjects t-test, and that's where you've got the same participants in the groups but they're just performing some task, or you're looking at their scores on a variable at different times, time A and then at a later time B, and comparing to see if they're different. So in this video I'm just going to focus on the independent groups t-test, so different subjects, different participants in the groups. In the next video I'll talk about the paired samples t-test. Okay, so let's get started on this. So I'm going to load the tidyverse. Excuse me. I'm going to load the tidyverse. I'm just going to save that because I didn't want to change my data set. So tidyverse is a package that's contains a number of packages that are useful for manipulating data and visualizing data. So the data that I'm going to use just to demonstrate the independent groups t-test, it's one that I've got saved on my computer, and I think it might be simulated synthetic data that I made up. If not, I can't remember where it came from, but I've got it saved on my computer as with the name weight height igt.test.csv. So it's saved as a comma separated value spreadsheet file, and it's data that the scores on it are kind of useful for demonstrating an independent groups t-test. So that's what I'm going to use it for. So I'm going to import that data first of all by creating a data frame object. I'm going to call it df. I'm using the assignment operator there, the keyboard shortcut for which is alt minus, and then I'm using the read.csv function or method. And as a string between double quotes, I'm passing in the name of the file. The name of the file is actually, I'm not having to put like a relative path or anything like that, because that file is already in the kind of workspace for this project, for the actual directory I'm currently I'm working in. So if we run this command here, you can see we've got in the environment window now here, we've got this new object called df. It's a data frame. 50 observations of 5 variables. Okay, so it's a small data set, 50 participants, 50 observations, we've got 5 variables. So if I use the glimpse function on df, you can see below in the console window, make it a bit bigger, you can see below in the console window, it tells us what the 5 variables are, and it gives us the first kind of 15, 16 scores on each of those variables. So we've got a participant ID, which is just the kind of ID number of the participants, not a useful variable as such, other than recording who was who. And then we've got weight and height, and these are the weight of a participant, the height of a participant, and we've got age, which is their age, and we've got sex, the sex of the participant. So they're the 4 things that we've recorded that are of interest in this data set. And you can see I like the glimpse function because it gives us the data type. So you can see weight and height are shown as DBL, or double precision. So they're recorded as decimals, continuous numerical values. Age is shown as for integer, which is because it's just an integer value for their age. They're 30 years old, they're 20 years old, etc. Sex is also shown as an integer as well, and it's shown as 0s and 1s in this particular data frame. So when I've imported the data frame, sex is dummy coded on that spreadsheet. So 0 is male, 1 is female, and R has just interpreted it using the most appropriate data type for the type of information contained within it. But this is the problem with this is sex is actually a categorical variable, or what's known as a factor in R. So what we're going to need to do is manipulate the data a bit, clean it up a little bit, so that the sex variable is shown as actually as a categorical variable and not as an integer value. Okay, so to do that, I could just overwrite the existing df object we've created here, but I'll create a new one and just call it df2. So I'm going to create df2, use the assignment. I'm going to take df, and then I'm using the pipe operator, so take df, and then I'm using the mutate function. What I'm doing is I'm using a logical kind of if-else statement. I'm saying take the sex variable, if else, if sex is exactly equal to 0, label it male. If it else, otherwise, in all other cases, label it female. So we've only got 0s and 1s for sex in this particular data frame. And then I've got an extra, after a comma there, I've got an extra bit of syntax I've got add, which is just saying change the 0s to male, change the 1s to female, and change the data type to factor or category. So sex equals as underscore factor, and then I'm just passing sex again. So let me run that, and we'll create a new object for us, df2. So we've now got df2 up there, and let's do a couple of things. Let's create a plot. If this has worked, so if we hadn't mutated, manipulated, cleaned the data in that way, if I try to visualize that data and create a box plot, it would just kind of, because sex is shown as an integer, it just averaged them out, and we'd only have one box. So it's always useful to visualize your data. But what we're going to do here is I'm going to take df2, I'm going to pipe it into ggplot. We're going to take the x-axis, we're going to put the sex variable, which we've just created as a factor. Y-axis we'll put weight, and we're going to create a box plot. And if this works properly, we'll know that we've managed to successfully create a factor, and it's no longer just shown as an integer. So you can see we've got our plot down here, our box plot, and it's kind of interesting to look at, always a useful thing to do. And you can see that we have got 2 boxes, so males and females. Okay, we've not just got 0, 1 and 0.5 with one box in the middle, which is what would have happened if we'd not addressed this issue with sex being shown as an integer. But something to note here, you can see males, the box for males is higher than females in terms of weight, so males seem to be heavier. So there seems to be a difference between males and females in terms of their weight. Is that difference statistically significant? That's what we use the t.test to evaluate. I'm just going to run the glimpse command again on df2, just so we can check that this int is now shown as a category or a factor. And you can see there it is. If you look in the output window below, we've got sex. It's now shown as FCT or factor. And the 0s and 1s have been replaced with males and females. Okay, so great. All right, so let's run some t-tests, or let's run we'll run 2. The first one is we'll do a non-directional t-test. Okay, so that's the default if we don't specify the direction of the prediction we're making. Okay, so to run a t-test, what I'm going to do, I'm kind of using the pipe operator because I like to do that. It's kind of it's sort of nice, intuitively sensible way, I think, to format the syntax for these types of analyses. So I'm going to take our df2 data frame object. I'm going to pipe it into the t.test. So that's the syntax for a t-test in R. It's part of the R base package. So there's a lot of statistical formulas contained within R, and t.test is one of them. And there's a number of arguments you have to specify. But what you can do here, which is nice, is specify them as a formula. So I'm saying take data frame 2, pipe it into the t-test. I want to do a t-test, and then I'm saying I want to take weight, the weight variable, and now I've got this tilde character and then sex. So what I'm saying is I want to do a t-test looking at weight as a function of sex, or weight by sex, to see if there's a difference. Is there a difference in weight between the sexes, between the two sexes recorded in that categorical variable? Then I've specified data. We've already kind of told it with the pipe that we want to use the data for df2, but I've done data equals and then a dot, and that's just kind of telling, that's just so we've got the correct number of required or positional arguments. It's just telling it to go back. The one we're going to use is the data that's contained within df2. So let's run this and see what sort of result we get. And you can see in the output window below, it tells us it's done a Welsh 2-sample t-test, weight by sex. We've got a t-value of 5.3543, degrees of freedom of 34.61 if we round that to 2 places, and we've got a p-value of 5.664 times 10 to the minus 6. So a very small p-value, so we'd have to move this decimal place kind of like 6 places to the left, so it'd be 0.00005. So very small p-value. So the null hypothesis for this test is that the difference in weight between males and females in this particular data set is 0. The alternative is that the true difference in means between the males and the females in terms of their weight is not equal to 0. And we've got a very small p-value, so what we're seeing here is kind of strong support, I guess, for the alternative hypothesis that there is a difference in weight between males and females, and it's statistically significant. Okay, and we can look at the group means. For males, the mean weight for males is 76.992. For females, it's 61.65. So males are statistically significantly heavier than females in this particular group. Okay, but remember, this was a non-directional hypothesis, non-directional prediction. And we generally do that if we're testing to see if there's a difference between our group, but we don't know what direction the difference is going to be. So are males going to be heavier than females? Are females going to be heavier than males? So we're looking to see, we might think there is a difference between the mean scores of the groups, but we don't know which direction it's going to go in. This group's heavier than that, or that group's heavier than this. But if we do have some information, which we do because we have a plot here, males, looking at our plot, we can already tell that males in this sample are heavier than females. Are they significantly heavier? Or we can add an extra argument to the test. So all I've done is copied that t-test, that same command that we ran above. So we've got our df2 data frame, we're piping it into t.test. The formula is the same, weight is a function of sex. We want to look at that. Data's the same, but I've then put this comma and then alternative equals greater. So we're specifying the direction of the alternative hypothesis. Okay, so we're saying difference in means is greater than 0 for the alternative for HA, as I've kind of put here in this comment. Okay, let's run that, and we will get we'll get similar. There we go. We'll get so the t-value is going to be the same. Degrees of freedom are the same. We've got a different p-value in this case, and it's smaller, so it's 2.832 times 10 to the minus 6. So it's still statistically significantly different. Obviously, our means are the same, but we've got a slightly different p-value because this time basically all the significance is contained in one. That 5% significance threshold is all in one tail. It's rather than 2.5% being split between each tail, because we weren't making a directional prediction previously. Because we've made a directional prediction, the significance is all in one tail and not split between the two. So we've ended up with a slightly different p-value. Anyway, that's about covers the independent groups t-test, independent samples t-test, between subjects t-test, whatever you want to call it. Pretty simple to do in R. There are other options as well. We could have, rather than specifying that we think the difference is greater than 0, we could have specified that it was lower than 0. And we can use syntax. If I just copy this, I'm not going to run it, but I'll copy it and show you. So we could do, we could have just put G, alternative equals G for greater, or L for lower. Let me run that and we should see, we get a similar sort of, there you go. So their alternative hypothesis in this case, true difference in means is less than 0. Okay, so I just ran it with G on L. There are other arguments you can use with the t-test. Okay, so that is the independent groups t-test. Thanks for watching and listening. I hope this was useful. In the next video, I will demonstrate how to conduct a paired samples t-test.